Okay, so wonderful good morning everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hamper Kliman. So yet we have another session on set theorem, and if you have a question, make sure that you inbox me on the WhatsApp line on the screen. So we start our set theorem, and then we are going to go deep in the next video sessions. But for this tutorial, ensure that you grasp the concept, and don't forget to hit the like button, don't forget to share, and don't forget to subscribe. So let's start. Exactly what is the definition of a set? Okay, what is a set? So a set is a collection. A set is a collection of well-defined objects. So it's just a collection of well-defined objects. Okay? These sets are denoted by big letters. So a set is denoted using big letters. For example, if we say we want to have a set A, then that set is going to be represented by the big letter A. If we want to have a set B, then that set is going to be represented by big letter B. If we want to have a set C, then that set is going to be represented by big letter C. Okay? In other words, if you were to present this on the Venn diagram, you're going to have two sets, or let me just say three sets, okay? And these sets are going to be represented by big letters. So you don't use small letters to represent a set. Instead, you use big letters. Under set theorem, small letters are used to denote a member. Okay? Small letters are used to denote a member. Okay? So in this case, if we have a set called A, then A is going to contain a member called small letter A. And at the same time, if we have a set called B, then this set B is going to contain a member called B. So in other words, we use small letters in order to represent members. Okay? We use small letters in order to represent members or elements of a particular set. So in this case, for example, if this is our set A, then A is a member of set A. In this case, we say that A is a member of set A. That is the operation there. If this is our set B, and this set B contains a member B, then we say that B is a member of set B. Okay? That is very important for you to understand. But if we have a set C, such that this particular set contains A, B, C, okay, and then we have a set B such that this set contains A, B, then we say that this set B contains the elements A, B, okay, then this set C contains the elements A, B, C. So if we are to use this operation here, we can say that A, B, are members of both set C and set B, but C is not a member of set B. Okay? Why? Because we do not have C element in set B. So these operations are very simple for you to understand, and you need to take note of them. Now, there are particularly two ways to represent a set, to present a set rather. There are two ways to represent a set. Okay? The first one is what we are calling as the roster or listing method or the tabular form. Okay, so we call it the roster, or you can call it the listing method. Roster, listing method, or the tabular method. How does this work? Well, in this method, if you have a set A, then for you to present set A, you are going to present it in this manner. You're going to have A, B, C, D, E. So this is the roster method or the listing method. Okay? Another way through which you can present this particular method, let's say you are dealing with vowels. You can say B is a set of vowels and you are listing them in roster or tabular method. Then this is going to be your A, your R, A, E, O, U. Okay? So in other words, you are just listing the elements. That's the only thing you're doing. The second method is what we are calling as the set builder notation. Okay? Set builder notation, which is very important for you to understand. In set builder notation, if A is a set, then we are going to say that X is such that this X, okay, possibly maybe could be a member of something, could be a member of a particular set, let's say A, okay, and this same X could be either natural numbers, whole numbers, or could be even numbers or even prime numbers, whichever you're talking about. So this is the best way we establish everything in set builder notation. So a very good example that I can give, okay, if for example you have a set A such that set A contains the elements 2, 4, 6, 8, okay, how do you present set A in set builder notation? To present set A in set builder notation, you're going to say that A is equal to, you open those curly brackets, you're going to say that X is such that X, okay, X is such that X, okay, is a group of even numbers or a set of even numbers, okay? Or let me just say it this way. Let me put it this way. You can say that X is such that X is even and that X is greater than 0. That is the best way to establish this particular set. Another example that I can give for this particular set, if for example you have a set B, okay, you have a set B, and at the same time, let's say this is going to be a set of, let's say you're going to have 0, 1, 2, 3, 4, Okay, let's just etc. etc. How do you write that in set beta notation? You say that B is equal to, so X is such that X is a whole number. And X is greater or equal to 0. Okay? So this is this set in set beta notation. So if you want to present this set in set beta notation, use this particular concept. 3. There are two types of sets. The first set is called the finite set. The second type of set is called the infinity set. A finite set is a set which contains countable elements. So in this case, if A is a set and it contains 1, 2, 3, then we say that A contains 3 members. These are countable. Henceforth, we say that A is finity. An infinity set is a set which contains uncountable members. Uncountable members. So if set B is a set of numbers which are like this, let's say 1, 2, 3, then etc., etc. These are uncountable numbers. You can't count them. Henceforth, we say that B is infinity. That's very important for you to understand. Now, another thing that I want you to understand is this. An empty set denoted by this is a finite set. Take note of that. It's very important for you to take note of that point. So, if we were to have examples, let's have examples. A is a set of 1, 2. B is a set of A, B, C. C is a set of A, B, E, F. D is a set of, let's say D is a set of rivers in Zambia. Sorry, rivers in the world. This set is finity because you can count. This set is finity because you can count. This set is infinity because you can't count that. You can't count the number of rivers in the entire world. So henceforth, even this set is infinity. That is one thing that you must be able to understand. Okay? It's very important for you to understand that particular concept. We come to a cardinal number. A cardinal number is simply the number of elements in a particular set. It is simply the number of elements in a particular set. It is denoted by the symbol, say N, A. Okay? The N is the number of elements. Number of elements in the set. So in this case, if you have a set A, let's say it contains 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, these elements, right? 7, 10. What is the cardinal number? To find the cardinal number, you say N, the number of elements in set A, then you count 1, 2, 3, 4, 5, 6. Henceforth, the cardinal number is 6. If you have a set B, and then it contains 1, 4, 6, 8, 10. Okay? The cardinal number of B is 1, 2, 3, 4, 5. And henceforth, it is going to be 5. Quite simple. We come to the empty set. What is the empty set? The empty set is denoted by this. It is denoted by it is denoted by this symbol, or important concept, the empty set is a finite set. The empty set is a finite set. Okay? That is very important for you to understand. The empty set is a finite set. Another important thing to understand is that this same empty set is a subset of every other set. An empty set is a finite set, and it is a subset of every other set. That is very important for you to understand. Please understand these concepts I'm teaching. What is a singleton set? A singleton set is a set which contains only one element. So in this case, if this is set A contains one letter, then we say that it is a singleton set. If this is set B and set B contains A, B, then we say that B is not a singleton set. Okay, that is very important for us to understand. Okay, I don't think I need to give examples on this because it is very simple. Let's talk about a subset. When we talk about a subset, what exactly are we talking about? Subset, superset, what exactly are these? Okay, when we say subset and a superset, what exactly are we talking about? Many people confuse these, but they're very, very simple. Okay? If all the members of set A are in B, then we say that A is a subset of B. And if there is one element in B which is not in A, then we say that B is a superset of A. Example. Let me give an example. If A contains this set, 1, 2, 3, and B contains this set, 1, 2, 3, 4, we say that A is going to be a subset of B. Why? Because all the elements in A are found in set B. Well, there is an element 4 which is not in set A. Henceforth, we say that B is a superset of A. If all the elements in A are found in B, that is a subset, then A becomes a subset of B. And if there is an element, or if there are elements in B which are not in A, we say that A is not a, we say that B is actually a superset of A. I think that is a very good example I would give. Okay, well, let's have an example here. Let's say set A contains the elements A, E, F, G. B contains the set E, F. Which one is a subset of the other and which one is the superset of the other? So I want you to give me this example. Okay, you give me this question, I'm going to mark. I want answers for this particular question. Okay, I want answers for this particular question. I want to see if people have understood this particular part. 7. When is a set equal and when is a set equivalent? When is a set equal and when is a set equivalent? Another example, if A is a set of, let's say, real numbers, 1, 2, 3. At the same time, if B contains the elements 1, 2, 3. Notice that the elements in A and B are equal. They are the same. Henceforth, A is equal to B. But if at all, we had 4 there, then we would say that A is not equal to B. And that is correct, because A is not equal to B. When is a set equivalent? A set is equivalent if the number of elements in A is the same as in B. Remember, I didn't say if they are the same, I said if the number of elements in A and B are the same. So in this case, if this is our set A, and set A contains, let's say, A, B, C, and set B contains 1, 2, 3. How many elements in A? There are 3. How many elements in B? There are 3. Henceforth, we say that A is equivalent to B. But if the number of elements in A and B were not the same, we would say it is not equivalent. Very simple concept for you to understand. Please understand what we have said there. Okay? It's very important to understand. It's very important for you to understand that particular concept. Okay, so this was what? This was 5. Let's give it, okay, this was 6. Okay, so this one, let's give it 7. It's very important to understand these operations. What is a proper set? A proper set, okay, let me put it this way. What is a proper subset? For a proper subset, if all the elements in A are in B, but there is at least one element which is not in A, like I mentioned in the other, at least one element which is not in A, then that becomes a proper subset. In this case, we say, let's say A is a set of numbers 1, 2, 3, 4, 5, 6, and B is a set of numbers 1, 2, 3, 4, 5, 6, 7. Notice that there is one element 7 which is not in A. Okay? Okay, so all the elements in A are in B, but there is at least one element in B which is not in A. Henceforth, A is said to be a proper subset of B. Okay, it's very simple concept to understand. Okay, what are disjoint sets? Disjoint sets are sets that have nothing in common. They have nothing in common. So in this case, for this particular type of sets, we say that if, let's say this is a set A. Okay, let's say this is a set A. It contains 1, 2, 3. And then let's say this is a set B. It contains Mweru, Tanganyika, Kafue. This is a set of numbers. This is a set of rivers. These lakes or rivers. So, there's no relationship between numbers and lakes. Okay? Henceforth, if we were to present this in the Venn diagram, we would say that if this is set A, then set A will have nothing in common with set B. Okay? This is how a Venn diagram is going to look like. Okay? That is how you present disjoint sets. So in this case, we can say that A, okay, is not a subset of B, and at the same time B is not a subset of A. There is nothing that is in B that is in A, and there is nothing that is in A that is in B. That is how you present these particular sets. Okay. Important to understand the universal set. Universal set implies the whole number of elements in a particular set. In a set. So in this case, if this set A, all the elements for dealing with letters, say A, B, C, D, E, F, all the elements in A, this is a universal set. It comprises of all the elements you can think of in a particular set. Okay? That is the universal set. Okay? Let's try to find the number of subsets. How do you find the number of subsets? Very important question. How do you find the number of subsets? The formula to find the number of subsets is given by 2 to the power n. In this case, if A is a set and it contains A, B, C, the number of subsets of set A, okay, the number of subsets of set A is going to be given by 2, then 3 on top, because these are the number of elements, and that is going to give us 8. Just count the number of elements in that particular set and find the answer. Okay, that is very simple to understand, also to grasp. Let's do power set. Very important question. Let's do power set. How do you find a power set? Look, if you have been given the set A, such that this set A contains the elements 1, 2. For you to find the power set of set A, represented by this symbol, this is how you do it. Remember, you start with the empty set. Why? Because we said that the empty set is a finite set, and at the same time, it is a subset of every other set. So, to find the power set, we'll start with the empty set first. You start with the empty set, then you get 1, you put it in this set. Okay, you say 1 as a single number. Then you get 2 as a single number. Then you combine the 2. Then 1, 2, like that. Then you found the power set of A. How about if set B was this particular set? Let's say A, B, C. How do you find the power set of B? Power set of B is given as this particular set, the empty set, and then A as a single letter, B as a single letter, C as a single letter. Combine the two. A, B, then combine the two. Then B, C. That is a power set of B. How about if C was given of this set? Let's say it had, let's say A, B, C, D. Power set of this particular set, sorry, I've forgotten one thing. I need to add the entire set, A, B, C. Then you are done. How about for this set? It's very simple. Collect the empty set first, then collect the single number, the single letters. So A as a single letter, B as a single letter, C as a single letter, D as a single letter. Combine A, B. Combine B, C. Combine C, D. Combine everything. So this is going to be A, B, C, D. Then you are done for everything. That is exactly how you combine everything when you are dealing with a power set. Okay? That is quite very simple for you to understand. So for this particular lesson, if you found this video interesting and very easy to understand, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much.